Okay, so we are talking about proportions in a single triangle today. We talked first of all about dilations, where you take one particular figure and you enlarge it or reduce it, right? And we said within that, what's the relationship between the image and the pre-image? What stays the same? What's different? Angles are congruent. The sides are proportional. And that's also true if you just take two random figures that are similar, right? Okay, to be similar, the corresponding angles have to be congruent and the corresponding sides have to be proportional. Well, we're talking about proportions within a single triangle today. And so we want to look at this first example here. And it says that in triangle JLN, if LN is 9.6, so this whole thing here is 9.6, what are LM and MN are the sides divided into proportional segments. So I'm looking for this length and I'm looking for that length, okay? Okay, so the knowledge that we have right now are similar figures. And we see we have a triangle within a triangle, right? Okay, so we have this red triangle and then we have the larger blue one, okay? And we know that the red and the blue are similar because they first of all share the angle L, right? And then since these sides are parallel to each other, you've got corresponding angles that are congruent. Okay? So we have another pair of angles that are equal. So the triangles are similar by what? Angle, right? Okay. So that means that we can set up a proportion, red to blue or little to big, right, on both sides, okay? So if I did that, I could take red to blue. What would the blue's lengths be right here? 8. Okay. All right. So I could say 3 is to 8 as x is to 9.6. And so we would cross multiply 3 times 9.6, 28.8 equals 8x. Divide both sides by 8, and you get 3.6. So, this x right here is 3.6, which means my y would be 9.6 minus 3.6 is going to be 6, right? Okay, so that answers the first two questions. LM is 3.6 and MN is 6, right? Now my second question, it says, are the sides divided into proportional segments? Okay, so we have this line here, KN. Does it divide the sides into proportional segments? Well, let's see. If I took 3 is to 5 as 3.6 is to 6, are those proportional? How do I determine that? I can cross multiply, I could divide them out. 5 times 3.6 is 18, and 3 times 6 is 18. So yes, the sides are proportional. Okay? Well, this leads us into a theorem, and it's called the side splitter theorem. Now, notice that KM and JN are parallel, right? The sides are going to be proportional when that happens. And that's what this theorem says. It says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So just like in the problem above, MN is parallel to AC. And so this theorem says that it divides the sides into segments of proportional length. Okay? All right? And so we can use that when the side is parallel. Now you still can use little to big, okay? And you have to use it, let's say, if it was asking me for Z and this was 30, okay? You would have to do red to blue or little to big, okay? Because these are not the sides of the triangle. These are on the left and the right, okay? All right, we'll do one like that here in a minute. Well, right now. Okay, what is the value of x in triangle PQR? What is the value of x? Now here's x right here. It's in PS. It's also in RT. Now, here are my parallel sides. Okay? Those are my parallel sides. And remember, it breaks the sides into parts that are proportional with each other. Okay? So, what would I do then to find x? Any ideas? Remember, this line here, ST and PR are parallel to each other. So it divides this piece here and this piece proportional to this piece and that piece. Okay? What is the length of SQ? 16. What's the length of QT? 12, right? Okay? So that's this piece right here. That's this piece right there. Okay? And then I have information about the bottom two pieces. If this line is parallel to that one, these parts here are proportional. So how could I set that up? 16 over x plus 2 equals 12 over x. Okay? All right, so we cross multiply and we get 16x equals 12x plus 24. Subtract 12x from both sides. That gives me 4x equals 24. Divide both sides by 4. Then x is equal to 6. So this ends up being 8, and this ends up being 6. Okay, so when this line here is parallel to the third side, it breaks the side of that triangle into proportional parts. But let's say I wanted to find Z. Z is not part of the sides that are proportional, okay? It is a part of the smaller triangle in the picture, okay? So in a situation like that, I have to go back to little to big or red to blue, okay? So what would I do to find Z? I would have to take a side of the red to a side of the blue, and then a side of the red to the side of the blue. What would that look like? You could use either side of the triangle. Where are you getting 12? Over here, to the right? Okay, now the whole side of the red is 16. So you would have to take 16, which is the side of the red, to the entire side of the triangle. What would the entire side of the triangle be? Huh? 24? Yeah. Because you would have to add 16 and 8 together, okay? So you would have to do 16 is to 24. That's red to blue, right? Red, little to big. And then you could do Z is to 30, okay? Okay, so we would cross multiply 16 times 30, which is 480, equals 24Z. And so Z is 20. Okay, so I had to do it like that. I had to take, this little triangle to the big, the little to the big, because I was looking for a side of, a different side of the triangle. When this is parallel, it breaks the other two sides into proportional parts. But the Z wasn't part of those proportional parts, so I had to go back to what we did in previous lessons. Okay, now, the next thing we want to talk about is what a midsegment is. Now, we talked about a midsegment of a trapezoid. You remember what a midsegment of a trapezoid did? Okay, the length of it was half of the two bases added together. Okay, that's right. But what made it a midsegment? What did it connect? The midpoints of the legs, right? Okay, So the mid-segment of a triangle is a segment of a triangle whose endpoints are midpoints of the two sides of the triangle. So this right here is a mid-segment because this is a midpoint and that's a midpoint, okay? And so it is also called a mid-segment, but it's a mid-segment of a triangle. The one we talked about earlier was a mid-segment of a trapezoid. Okay, but they do have some similar characteristics. Your mid-segment of a triangle is parallel to the third side of the triangle, and then its length is half the length of the third side. In the trapezoid, you had to add them together and divide by 2. It's just half. So if this right here was 16, then what would GH be? 8. Okay, so it's half the length of the third side, and it's parallel to the third side. And it's a mid-segment because it connects the midpoints of the two sides of the triangle. Okay, so that's what a mid-segment is. All right. In the figure, XY and XZ are mid-segments of triangle RST. Find the measure. So, XZ is a mid-segment, and XZ and XY. Those are both mid-segments, okay? All right. So, XZ, we want to know what its length is. Well, if it's a mid-segment, what's its length going to be? We just learned that the mid-segment is half of the third side, right? What's the third side? 13, right? This is the third side. Remember, those are parallel to each other, right? And this is going to be half of that. So half of 13 is what? 6.5, okay? All right, what about ST? I need ST, and my mid-segment is 7. So what's ST going to be? 14. Okay? Now I need the measure of angle RYX. This is angle RYX. What can I do to find that measure? Okay, good. The red lines that are parallel to each other, okay? And so if those are parallel, then what relationship is this going to have? What's it going to be? Alternate interior. Okay, so it's alternate interior with this 124 degrees, and alternate interior angles are equal, right? So it's going to be 124 degrees. Good. All right, any questions on that? Okay, there's a lot in this chapter, honestly. Okay, now here's a corollary to the side splitter theorem. Okay, it says if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So it's kind of like the side splitter theorem, but the side splitter theorem was with a triangle. These aren't necessarily triangles, but you have 3 parallel lines and you have 2 different transversals. Okay? Well, if these are parallel, then these transversals are broken into proportional parts. So I could set up a proportion. AB is to BC as DE is to EF. Okay? So these parts are in proportional parts. I could also go across, and I could do AB is to DE as BC is to EF. I could do it like that too. Okay? But when you've got the 3 parallel lines and the 2 transversals, those transversals are broken into proportional parts. Okay? All right. So let's do an example. It's a little bit hard to see. I'm going to rewrite these numbers. This is X. This is 60, 24, Y, 72, and 24. All right. It says a reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street, which are parallel to each other. Okay, so basically, we've got these 4 lines here, and they are all parallel. Okay. The city wants to add additional tiling around the pool. How much tiling does X feet represent? How much tiling does Y represent? Okay, so if these are all parallel to each other, these are my 2 transversals, what can I do to find X? Any thoughts? What do you think, Will? Think we can figure out what X was? Make a proportion. What would my proportion look like? 24 is to x as 72 is to 60. Okay, that would work. Could I have done 24 is to 72 as x is to 60? I could have done that too, right? Okay, good. All right, so I'm going to cross multiply. So 24 times 60, 1,440 equals 72x. Okay, divide both sides by 72, and x is equal to 20. Good. Okay. What do you think we might do to find y? Something similar? What would that look like? Perfect. 72 is to y as 60 is to 24. Okay, so we're going to cross multiply again. 72 times 24, 1,728 equals 20y. Divide both sides by 20, and I get 21.6. I think I did something wrong. 72 times... Oh. You are right. I was going to say, I didn't think that answer was right. Where did I get 20 from? I must have pulled it from the top there. Okay. So 1728 divided by 60, which is 28.8. Okay, so 28.8. All right, any questions on what I did there? That's pretty easy, okay? Now, this next theorem that we're going to talk about is one that people tend to kind of forget about, or they kind of try to make up their own theorem, and it's not usually right. So make sure you understand what this theorem is, okay? Okay, it's called the triangle angle bisector theorem. And it says, if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Okay, so you look at your picture, and you see that you have an angle bisector, okay? Now, it's an angle bisector, but does it bisect the opposite side? No, okay? This is an angle bisector. What it does is it breaks the opposite sides into a ratio that's the same as the other two sides. So if I did 12 is to 16 as 6 is to 8, those are proportional to each other, because 12 16ths reduces to 3/4, and so does 6 8. Okay? So it breaks the opposite side, A is to B, as AX is to BX. Okay? So it breaks the opposite side into a ratio that's the same as the other two sides. Now, so I can do, left to right, left to right. I can also take this side, UX, is to its adjacent side, UV, and then this side, WX, is to its adjacent side, WV. Okay, that would work also, either way. Okay, so we need to do a couple of examples here. What are the values of AD and DC? So we got to find X, which is AD, and then we want to find CD. All right, so first we look at our picture. We see, what do we have right here? What is BD doing? It's bisecting that angle, right? And so that tells me that it breaks the opposite side into a ratio that's the same as the other two sides of the triangle. Okay, so, but this one's set up just a little bit differently. AD is X, the whole thing is 13. How am I going to represent CD? We don't want to use Y because that introduces another variable, but we could use it in terms of X, and that would be 13 minus X, right? Okay, so once we get that set up, we can now set up a proportion. What's my proportion going to look like? What'd you say? Okay, he's saying 10 over X, and then 16 is to 13 minus X. Okay, that would work. Okay, could I do 13 minus X is to X as 16 is to 10? Would that work? That would work too, okay? We'll go ahead and go with what he came up with. That's fine. I just want to show you there's really kind of two ways to set them up, okay? Okay, then we cross multiply, we get 130 minus 10x equals 16x. Okay, we're going to add 10x to both sides. We get 130 equals 26x. And 130 divided by 26 is 5. So, AD is my x, right? So then what's DC going to be? 8, because it'd be 13 minus x, which would be 8. Okay, we got one more, and then the bottom part's just the recap. Okay, we want to find the value of x, and then GH and GK. What's the first thing we notice about our picture? It's an angle bisector, right? Which means the opposite side is broken into a ratio that's the same as the other two sides, correct? Okay, so what are we going to do to find x? Any thoughts?
3x.
All right, 3x plus 3 is to 3x minus 7, as 18 is to 12. Okay, that'll work. Cross multiply, we get 36x plus 36. What's 18 times 3? 54. 54x minus 18 times 7. 126. Okay, so we would subtract 36 and 54, which is 18x, and then add 126 to both sides. 162, and then divided by 18, and so x ends up being 9. Okay, so x is 9. That answers part A. Then it wants GH and GK. GH, plug 9 in there. 9 times 3 is 27 plus 3, so GH is what? 30. Okay, and then 9 times 3 is 27 minus 7, which is 20. How else could I have set this one up? What was the other way? Does anybody think of the other way? Could I have done left to right, left to right? Yeah, you could have done that. Okay. All right, so we basically learned 3 things. Okay, we learned the side splitter theorem. If you have one side of a triangle that's parallel to the third side, then it breaks the other 2 sides into ratios, into proportional parts. So A is to B as AX is to BX. Okay, then we talk about the midsegment. The midsegment connects the midpoints of the 2 sides. Okay, it's parallel to the third side, and it's half the length of the third side. So if GH is 10, what's DF? 20. Okay. Then we did the triangle angle bisector theorem. Okay, you see this is an angle bisector, and it breaks the opposite side into a ratio that's the same as the other 2 sides. Okay. All right, any questions? Okay.